Okay, folks, this is Al Morton here. I'm just sharing my video in a few, for a few moments here. I don't think I've got the bandwidth to continue to do that. So I'd just like to say hello. Thanks for joining the BMWG session. I assume that folks in the room can hear me. I can see you on video. If you can hear me, just wave your hand. Thank you. Thank you, all three of you who are waving there. Good to see you. Okay, and Vlad joined the queue. Go ahead, Vlad. Oh, now he's gone. Okay. Sounds good. All right. And we had a chat. Yes, Boris said we can hear it. Very good. Okay. So Warren's joining us right now. In fact, there he is. Warren will be our AD advisor and sergeant at arms in the room. And as I said, I'm Al Morton, one of the co-chairs. Based on the messages from Sarah, I'm not sure whether she will be able to join us today, but we will muddle onward. So this is the benchmarking methodology working group session. And we got a couple hours here. If you're not subscribed to a BMWG mailing list, this is the place where you can do that. Okay, note well. The special note well for our group is that we work as individuals, we try to be nice to each other. That's usually pretty easy to do. We all have a common interest in testing here and benchmarking. So let's just leave it at that. You've seen the IETF policies probably various times while participating in the meeting. So feel free to delve into this further. Basically, any contribution you make at the meeting could be a statement at the microphone, email to the list, all sorts of things of that nature. So they're all subject to IETF's policies and procedures. So here's our agenda. We've got the status and the proposals and adoptions to talk through. We've got the multiple loss ratio search. We've got some slides on that. That's actually 03 now. Quick update on next generation firewall. We've got some new slides for the Yang data model and also slides for the benchmarking methodology for stateful NAT-XY gateways. I've uploaded all of these. If you can't see them, I guess it's because the system is lagging behind the updates. So, I'm sorry for that, but don't worry, we'll get the slides presented in any case. And then we'll be looking at proposals here, the considerations for benchmarking network performance, containerized infrastructures, also methodology for MPLS segment routing and V6 segment routing, and problems and requirements for evaluation of integrated space and terrestrial networks. So any bashing of the agenda needed? Hearing none, then we'll just go ahead with that. So it's important to point out that there is there's a really easy note taker facility here made available in Meet Techo. Obviously, I'll be trying to take a few notes as we go along, but if anybody else would like to jump in and help type a few notes on the questions and answers that come up, that would be great. So please help out if you can. We've got a fairly easy way to follow the Jabber. I can bring that up pretty quickly if I see an alert for that. But if somebody else sees a note in the Jabber and I don't see it, feel free to go to the mic and bring it to my attention. Thank you. All right. So I think we're good there. The status is that we've got all the IESG discussed ballots have been resolved. Got a large rewrite that's come to fruition on the multiple loss ratio search. It looks like some good progress there. We've adopted the Yang model draft and also the stateful NAT XY gateways drafts. And we've still got lots of proposals to deal with. So I encourage people to read the proposed drafts and give us some comments. That'll be a basis for considering, what we begin to adopt and when. And we've got some drafts in that list that have really shown, lots of progress and lots of, hackathon work and lots of, new drafts and additional work going on. So, there's additional work we want to adopt there, I think, and I encourage you to consider those drafts. When you join the group, it really helps out if you do some reviewing. So that's the way to really join the community here. So thanks for doing that, and when the time comes, please volunteer to review some drafts. Okay. So no new RFCs, but our charter's been fairly stable for quite a long time. If you're looking for information about how to join the group or how the group operates, we have a supplementary working group page. It's hosted here. So feel free to take a look at that and get in touch with the chairs if you have any questions. And our milestone situation is where we've done with the first three, and we've got some work to do on some of these others. I don't think we've got much progress going on the automation drafts that we were seeing for a while. So we may consider dropping this. And we also have to add a milestone for the benchmarking for stateful NAT XY gateways. So that's some background work that the chairs have to pick up, but we'll do that in the fullness of time. So any questions about the working group status? Okay, very good. So let's see what we've got slide share wise here. So I see that, for whatever reason, multiple loss ratio search made it into the decks, the easy decks to share. So I'm doing that one. That's our next deck up here. And I see that we have Masiek and Vradko both present today. So who of you guys will be doing the presenting today? Looks like Masiek.
Hi, everybody. Hi, all. Hopefully you can hear me.
Yeah, we can see you and hear you, Masiek.
Excellent.
Welcome.
So we actually presented together. I'm going to do the first few slides, and then I'm going to hand over to Vradko to talk about next level of detail. So if audio and the feeds are going ahead, then let's get going. So welcome everyone again. we have posted the third revision of the slide after the deadline, so apologies for that. It is a bit of the rewrite, as Al, you already mentioned. Al, can I move the slides, or can you move the slides for me?
I have to do it, so sorry for that.
Okay, so next slide, please. Okay, yeah, so we posted the updated version on the 9th of November. We did not manage to push it before the deadline, and the draft is still very much a work in progress. Next slide.
Okay.
So what are the major updates? We had very good feedback from the working group, thanks to Al, Gabor, and Vladimir. And it made us realize that we need to actually spend time to better articulate two things. First, spend more time on articulating the problem statement, and then approach basically describe the approach to each and every of those problems that we are proposing with MLR search methodology, and supported by the code we have been running in the LFN FDIO SysID project. So this is what the third revision is about. It is a major rewrite. The concepts are very much the same, but we did spend time to really separate the problems. So again, thanks to, I think it was Vladimir who articulated it very well in one of the emails about a year ago, I think. So, and we also have done another thing. We have applied stricter discipline in terms of the terms we're using. So we have been using a number of terms from the open source project. We have a revised number of BMWG RFCs, 1242, 2285, and 2544, of course. And we have reference to the number of terms there, including offered load, maximum offered load, forwarding rate, and forwarding rate at maximum offer load, and such. So those references are now there and are used quite strictly in our review when we describe the methodology. What we have removed from the draft is direct references to the implementation. We realize that they may have been long and sort of meandering and confusing, and some of them got a bit outdated. Radko will talk everybody through the versions of the MLR search as the methodology evolved a bit. And really the focus on problem statement and the explanation of methodology, we are targeting the BMWG community to help us harden both of these, and of course, you know, validate them as a first and foremost. Next slide. So a quick recap on what multiple loss ratio search is, or why we're doing it, and what are the goals. So MLR search is about improving and enhancing the throughput search that is specified in RFC 2504. And just to emphasize it, it's about enhancing and improving, not replacing. And in fact, MLR search is compatible with RFC 244 throughput search with certain input parameters. What is driving us to define this improved network throughput search is the challenges we have faced when testing NFV systems and other software-based networking systems. What is specific about those systems is that we do need to execute a large volume of those tests for those systems, and also the behavior there is not as deterministic as we have seen with hardware and networking systems. So the three objectives or three goals that we are aiming to address with the MLR search are: we want to minimize the overall duration of the test execution. We want to search multiple loss ratios, so performance of the device at different loss ratios, including zero loss. And we also want to improve the results repeatability and comparability across implementations of the MLR search and throughput search, and across instances of execution, including between the different labs. Next slide. So the bullets here are really related, are corresponding one-to-one to the sections or subsections in the latest version of the draft. So we have split the problem statement into the sort of 5 points. The first one is about the long test duration. Throughput search, as specified in RFC 2504, is just too slow for software networking, specifically for environments where the continuous test execution is part of the development pipeline and of evaluation pipeline. So covering, it's basically executing a number of tests, covering multitude of different packet processing modes and different configurations. So we need to basically reduce the overall execution time. Second problem is related to what we are testing, the system that we are testing. So we have within the draft, we are distinguishing between the DUT and SUT. DUT being the actual software program, software processing packets, which is of interest to benchmark. SUT is everything that is around to make this software run. It's a server HUD, it's an operating system, and with shared resources and potentially other software programs running on that very system. So we refer to it as DUT being effectively nested within that system. And we also recognize that the performance that we are measuring from outside, the SUT performance, is a spectrum, and what we are after is the noiseless end of that spectrum. Repeatability and compatibility I already talked about. It's about being able to reproduce the results easily and compare. The other aspect is measuring the throughput, but with non-zero loss. We've observed in the industry that what is common when testing NFV and software solutions, networking solutions, the zero frame loss is not as popular as the non-zero frame loss. And we would like to capture that and make the search procedure user-friendly to allow people to and the labs to characterize a range of performance, not excluding zero loss, but rather adding the non-zero loss performance and do it in a systematic manner. And the last one is related to inconsistency of trial results that may happen during the search, and the search approach needs to be able to handle those, especially when we are searching for both non-zero and zero, and when we encounter a non-zero loss trials that are with smaller load, that are smaller load than for zero loss trials. So handling the inconsistency in the deterministic manner is one of the problems that we have also would like to recognize. Next slide, please. So we included the terminology update. It is much more compact than the previous versions. Again, we are referencing existing specifications from the BMWG. The three major ones are, well, the throughput as defined in RFC 2544, no change there. It must be zero loss. And then we are introducing something we refer to as conditional throughput. And the term we're using is for non-zero loss. And it's a throughput that is measured under, with a number of conditions. It coincides, it's equal to the throughput when the loss ratio goal is set to 0. But in fact, it is referring to the forwarding rate as specified in the RFC 2285 for non-zero loss ratio goals. Another important terminology update is the lower upper bound. We're using this term quite heavily when describing the methodology. They are usually relative to they're always relative to the current search phase, and it is actually the handling of those bounds that is the crux of or the core of the efficiency of the approach. So with that, Al, would you mind going to the next slide? And I would like to hand over to Radko.
Hello, this is Radko Polak speaking. So I will continue with top slides. So we have simplified the description of MLR search. We are no longer calling it an algorithm. We are calling it a methodology because some pieces are missing, but this is the main structure. So first of all, there are main inputs which control what the reported value will be at the end. And as mentioned, there is loss ratio goal, which can be 0 or non-zero. And there is target trial duration, which governs how long the final trial should be, the one that will be turned into the result, and also target precision, basically when doing the binary search at the end, how close the lower bound and upper bound should be. The search happens as a sequence of phases. There is single initial phase, and then there are multiple middle phases and final phases. By the way, in earlier draft versions, those middle phases were called intermediate phases, but now it was this name. So the initial phase is there to kickstart the other phases, and it is also a source of time spent compared to the usual approaches. Basically, we are doing 3 trials. One is done at the maximum offered load. Another one is done at the frame rate, at the forwarding rate of the previous trial. And once again, we use forwarding rate of the second trial to use as the load for the third trial. And there is MOL and FRMOL terms already defined in RFC 2285, and we just introduce FRMOL the next iteration. Turns out FRMOL is working good as an upper bound, and FRMOL works good as a lower bound. In the definitions of upper bound and lower bound, we allow each bound to be valid or invalid, so it does not matter if FRMOL load still leads to non-zero loss. The middle phase will handle it. Speaking about the middle phases, now we are explicit. There are 4 actions executed in that middle phase, so we are not calling it optimizations. There are specific 4 actions that are always attempted, not always needed, but always evaluated. No space to go to there, but the important thing is that each middle phase needs starting bounds, like starting lower bound and starting upper bound, which usually come from the previous phase, but not always, and turn them into the ending bounds. We we are still debating how to improve the terminology. Usually I say something like there is a phase goal, which includes trial duration for that specific phase and so on. So we still need to clear that out, but the idea is clear. We are iteratively improving and getting closer to the target trial duration and target precision. And we are using the fact that middle phases are shorter than final phases. Speaking about final phases, the logic there is exactly the same as the middle phase, but the name is different just because this is the phase that uses the target trial duration and target precision, and also the lower bound, more specifically forwarding rate at that lower bound. This is the quantity that is returned as the conditional throughput. And there is one final phase for each ratio goal, and sequence of middle phases is preceding each final phase. So there is final phase for the first goal, and only then start middle phases for the second goal, and so on and so on. Okay, next slide, please. Yeah, this is way too complicated, so it is not important for you to understand every little detail here, but this is basically an explanation of why the draft is changing so much. So there is a table. The table has 5 rows. Basically, each row is one implementation of the MLR search, and the logic of that implementation is different. So there are few columns, and this is an example that when one column changes, that needed significant edits in the draft text. So version 01 of the draft was using the first column, version 02 was using the second row. This is what we are still running in CSIT production. Version 06, which is not now uploaded, mostly is matching the next production ready code, which we are not yet using, but we'll be using in the next release. And the reason why we spent so much time writing this draft and removed most of the detail is the row number 4, where I had an idea and implemented it, and then decided the time gains are not good enough, so I'm already planning number 5. And I expect that version 04 of the draft will be describing the row number 5, or maybe even something more. So there are subtle changes. I will talk about the big one later. And this is why we are not describing all the details yet in this version, because, as I said in some previous presentations, this draft started as a description of an algorithm of code that we were running, and we are only now abstracting it so that there can be just one specification for MLR search methodology that is compatible with multiple different code versions, and all of them can be called MLR search. We are not there yet, but we are hoping to get there. Next slide, please. Maybe it will be good to talk about the second point first, because I started to talk about it in the previous slide. There is compatibility with binary search and with loss verification. That is another extension of RFC 2544, which was used in RFC 900. The last number but it is possible to introduce more input parameters to MLR search and turn the MLR search to be compatible with that. Basically, you can implement binary search with loss verification inside the version 4 of MLR search. And this will be another tool for people who wants to get more stable results, even with facing with SUT that has large spectrum. So there is big difference between load that almost always gets zero loss and load that almost never, but sometimes gets. So we are hoping that this will be more useful for the community, but we were not able to describe it in this version. There are too many changes in the terminology and how the algorithm handles it. Also, this 0.3 version does not address the important question of inconsistent trials. This is somehow related to, once again, two ends of the SUT performance spectrum. You can use decisions that prefer one end or other end, but this is very important for comparability. If you have one implementation that prefers one end and the implementation that prefers other end, it is natural that one of them will be reporting a lower number than other, even when testing the same DOT. And those decisions need to be introduced in the definitions of lower bound and final phase goal will probably not be the name in the next draft version, but basically some of the definitions that are in the 0.3 versions are not strict enough, so the comparability is not guaranteed.
Yeah. Hey, Bretko, I'm sorry, we need to wrap this up.
Okay, so basically the last item is what we as authors want from BMWG. Basically, we want to review, focus on the problems, because the problems is the part that we are happy with. And if community agrees these are the problems, we can proceed in describing the solutions in next draft version. Thank you.
Thanks, Masiek and Bretko both. And so I think that you've got a work in progress here that's on its way to the state where you want it to be. And I suppose if folks have a chance to take a look at the current draft, especially if you've read it before and see the direction it's changing, see the direction it's going, maybe that would be good feedback to our co-authors here to either let them know they're in the right quadrant or how much more they've got to do. So that's great. Thank you both for your efforts in preparing this, and we'll hopefully have some more comments by the next time we get together. Okay, so our next topic is the benchmarking methodology for network security device performance. And there's no slide deck on this today, but let's see, I got a chat here. So, yeah, okay. There was some chatting there off during the presentation, and that's good. I think it's been resolved. Good. All right, of the last draft. So let's work on. Let's go back to this security device performance. All the discussed ballots have finally been resolved. That took about 8 months, but it was a lot of work by the authors to deal with many comments here and obviously discuss ballots or blocking. The main question is I don't think the approved announcement has been sent for this, And so we're sort of looking to Warren for a timeline on when he can review the latest draft and maybe release that approval announcement. But I'll wait till Warren's back in the room to pursue this a bit. Okay, so moving on to the next topic, which Vladimir has supplied a couple of slides for. We've got the Yang data model for network test error management. And, oh wait, Warren's here. Warren, did you hear my question?
Yep. Yeah, Warren's been here. He just, I guess, sitting off camera, so you didn't know. Yep. Hopefully, sort of just after the IETF meeting finishes, I'll be able to send that. Just need to go and review and make sure they're all met. But yeah, I think that the discuss was cleared just before the meeting. So yep. Hopefully, just after the meeting, I'll be able to do one final review and then click or sort of do the final approval bit. So yep. And would you prefer me
That's
to be
great.
sitting at the front desk? I'd figured often the sides better out of the way, but whichever you'd prefer.
Well, I just wanted to be able to see when you're in the room and not, so that yeah, so that I don't talk about you. But which is, the only thing I have to say are good things, Warren. But I guess wherever you're sitting, it was off camera, and right there I can see your hat, so that's great. Perfect. Thanks a lot. Okay. Well, so that I think that's a really good outcome, and we thank the co-authors for all the really hard work on the security devices draft, and we'll be looking forward to your final review there, Warren. Much appreciated. All right, so let me see if I can now find and present the Yang model drafts. Yeah, for some reason they're not showing up in the decks ready to be shared. So let me look at the updates here. Oh boy. Okay. Meeting materials. So they're in the meeting materials. I'll refresh this. Back to preloaded. Still not showing up. Okay. So I'm going to share my screen. And I'll share screen 2. And here you can see I uploaded this deck, but when I go over to the preloaded slides, when I go over to the preloaded slides, Yang is not showing up. So back here, then okay. So I can't see the queue right now, and I can't see the the mic situation. But so if you need to make some comments here, just make some noise, and I think that'll work fine. Vladimir, are you ready to go?
Yeah, it's not a big WAS with all the slides. It's not like a great deal of detail in there, so I can just go quickly about the slides, and if someone is interested, he can probably download them later. Can you hear me?
Yeah, I can hear you fine, and like I said, the slides are available for download.
Yeah, so I can just go quickly through the slides. So the first slide is draft status, and it's work in progress. there are no outstanding issues raised on the list right now, and the running code is in a okay shape with significant yet not full coverage of the module features. So we have single stream, not a multi-stream implementation yet, and a very basic modifier implementation, a single 16-bit modifier, which was just implemented during the London hackathon. So going to the next slide is a description of the draft changes from 0 to 1 version of the draft, which was submitted to the mailing list some weeks before IETF conference, and it's pretty much the same what stays in that email. That's what the slides contains. It states one, modifiers are added, dynamic data field update functionality to the generator module, an example configuration where action type, which can be either increment, decrement, or random, offset, mask, and repetitions count parameters can be specified. And this is not uncommon for many of the proprietary traffic generators. So you can specify, in a way, portion of the frame that has to be dynamically changed. So you can increment or decrement this field. So it seems it's quite flexible what we have in the draft now, and we might need to constrain it a bit because it's not only 16 bits or 24 bits modifiers you can specify. Currently it's like a bit field which specifies the mask, and it's not constrained in any way. So we should consider some sort of constraint so that it's not impossible to implement it without deviation. This is to be, I'm thinking about that, and we should probably have a discussion and decide on something there. But for now, it's open. Second point is removed were the Ethernet specific static data fields, like specifying source MAC address, destination MAC address, and Ethernet type, which existed, but they were subset of the flexibility provided by the general frame data mechanism, which is what most of the people programming this generator will be using anyway. So having this redundancy just increase complexity and puts dependency on one technology, which I don't think is necessary. So it could be just removed without having all the issues with properly defining it. And the third point in the changes is the editorial changes which were made proposed on the mailing list, and they're now applied. So this is going to the next slide, which summarizes the hackathon activity, and it's not much. We just added the simplest implementation of this kind of modifier, which just takes from the configuration this single modifier, which it is a list in the model, but the implementation just fails everything that has more than one modifier. So it just takes the parameters for this modifier and allows you to implement a basic RFC 2889 benchmark. Like you can flood a bridge with incrementing MAC addresses and determine what is its limit. That's like an application that proves the concept. That's why this was added, because otherwise it wouldn't be possible to implement such a benchmark, or it would be extremely slow. Like you need commit transaction for each MAC address you want to add to the table. That would be useless, slow. So and another thing that was worked on the hackathon was resolving issues with the two chains, upgrading to updated dependencies with the latest version of Debian and Python 3, and other boring things that are not. I'm not going to go into detail there. And there is a slide which publishes all the links and the topology of the design of that reference implementation. So that's there. When you have interested, you can always download it and check where these repositories are and what is being committed to them. And the last slide contains image from the hackathon, and it's named the end. So this is just a picture of the table of the setup and the main screen in London. So that's the presentation.
Very good. Well, thanks for that update, and thanks for continuing to pursue this, simultaneously with running code and in the context of the hackathons. Did you have any interest, any folks asking questions at the hackathon, Vladimir?
Not much interest in during the hackathon, and especially this one. I mean, I just have to be honest. It was very little like a cross-domain cooperation on our table. So I have had some success with the people interested on other venues, like FPGA conference here in Norway. So I'm trying to find from 3 different areas people that are interested, like the networking world in IETF, the test world is a different segment which also is interested in this kind of models and devices, but they don't seem to have the background for young yet. And the FPGA world is also another community that has a stake in this work. So it's I'm trying to figure out how to involve people and create interest. But particularly in the London, we didn't manage to get any kind of interesting connections. Yeah.
Okay. Well, I'm sorry about that, but I'm hoping for more interest for us in the future.
Well, when I say that, there were people reading the material and checking the implementation. So maybe this comes later on. I don't know.
Maybe so. Maybe so. Well, we'll see.
Okay. Thank you.
Very
for
good. Good. Thanks a lot. Any questions about Vladimir's presentation? I don't see any requests for the floor, but I do see a. Okay. Oh man. Screen share. Did you guys see the slides I was presenting? Hello? Did you guys see Vladimir's slides in the room?
I didn't see them.
So you couldn't see him in the room. So when I'm sharing the screen, right now I'm sharing the note-taking screen. Can you guys see that?
Yes, I can see it.
Okay. All right. So I don't know what went wrong last time, but I'm going to stop sharing this, and I'm going to try this again with Gabor's slides. So hang on a second, because I don't see. Yeah, I still don't see Gabor's slides in the decks ready to be shared. So I don't know why that's being held up. There seems to be some really long delay there. But if I if I share my screen and I share screen 2, then now you guys should see a version of the, the BMWG Miteco page that converges on infinity. Would somebody confirm that?
I can see it. I can see it.
Okay, good, thanks. And then if I bring up a slide deck here for Gabor, which is basically this one, can you guys in the room see this?
Yes.
Okay. So I apologize if people couldn't see the slide deck. Last time I did exactly the same steps. And Gabor, why don't you go ahead and work your way through these. Try to take about no more than 15 minutes, okay?
Okay. Okay. Can you set the slideshow full screen?
I don't know.
I'm not sure.
Yeah, there we go.
Yeah, it's much better. Yes, it's much better. No, it's full screen. Thank you. Thank you. So our draft is about the benchmarking methodology for stateful NAT/XY gateways using RFC 4814 pseudorandom port numbers. Could you go to the next slide? That's right. Thank you. So in one slide, we just try to summarize the aim of our draft. So our aim is to achieve some reproducible stateful NAT/XY performance measurements, producing meaningful results. And to that end, we want to facilitate to carry out the measurement procedures of all the BMWG benchmarking RFCs like 2544, 5180, and 8219, and all the measurement procedures they define for throughput, latency, frame loss rate, etc., to benchmark stateful NAT/XY gateways. Without some careful thing, it's not possible, especially if we would like to also comply with RFC 4814 pseudorandom port numbers using them, because through the stateful NAT/XY gateways, you cannot just send through packets with any random port numbers. So we had to reconcile the two requirements, and we also added some new performance metrics for typically stateful benchmarking, such as maximum connection establishment rate measurement and connection tear down rate and connection tracking table capacity. Could you go to the next slide? Thank you. So the progress of our draft, I'm very happy that during summer at IETF 114, our draft has been adopted by the working group. Thank you very much for everybody for the support. And since then, we submitted 2 versions. Version 0 was just a little update. We added stateful NAT/XY, stateful NAT64 gateway as an example, because previously only stateful NAT44 gateway was an example, and we did some consistency checking and corrections. And in the next version, the current version, we added some more. We added some recommended some measurements for scalability, agents number of connections, and agents number of CPU cores. And we also added a recommended reporting format. Could you go to the next slide? Thank you. So this is the slide which contains which we added this stateful NAT64. Of course, our methodology works with any IP version, but it was an idea that not only NAT 44 but 64 should be displayed as an example. So just a quick reminder, we have 2 devices, the tester and the device under test, which is now the stateful NAT64 gateway. And as I said before, you cannot send just arbitrary packets through this gateway. And connections can be initiated only from the IP version 6 side. So it is on the left side of the figure. So this is why the port on the left side of the tester is called initiator, because it can send any frames, and then the stateful NATXY gateway translates the frame and records a connection tracking table entry and forwards it back to the responder port, which collects source IP address, destination IP address, source port number, destination port number information. It's a 4 tuple into a state table. And then after that, of course, exchanging source and destination, it can send back valid frames, valid test frames, which the stateful NATXY or 64 gateway will be able to forward. Could you go to the next slide? Thank you. So the basic idea is that we defined a preliminary test phase, which serves two purposes. During this preliminary test phase, the connection length table of the device under test is filled, and the state table of the responder is filled with valid 4 tuples. So after that, you can do a real test phase in which you can execute any of the classic measurement procedures like throughput, frame loss rate, latency, etc. And in addition to that, this preliminary test phase can be used alone as a measurement phase for maximum connection establishment rate. Could you go to the next slide? Thank you. Now this is a new material. Yes, okay. This is the one more reminder slide. Yes, to support repeatable measurements, we can achieve two extreme situations, which can be simply ensured. The first one is when all test frames create a new connection. This is ideal for measuring maximum connection establishment rate. And the other extreme situation, when test frames never create a new connection, this is ideal for the classic tests like throughput, frame loss, latency, etc. And the conditions to achieve them is that we should start each elementary test with a large enough and empty connection tracking table, and we should pseudo-randomly enumerate all possible port number, destination port, source port number, destination port number combinations in the preliminary phase, and we should set the timeout in the device under test properly high to be higher than the preliminary test phase, the gap between the two phases, and the real test phase. And if we do connection teeing down testing, then it's even higher than the additional phase for teeing down the connections. Please go to the next slide. Yes, and there was something in RFC 8219 in section 10 that it mentioned tests with several network flows, although it didn't specify exactly how to create several network flows, for example, using multiple source IP addresses, multiple destination IP addresses, or multiple source port numbers or destination port numbers. In our draft earlier, we recommended to use only a single source IP destination IP address pair and using a fixed and larger source port number range, for example, in the order of 10,000, and we should use a variable size destination port number range. It can be as small as 10 or 100, or it can be larger, and by changing the size of this range, we can generate the required number of network flows. And of course, if it depends, the granularity depends on the purpose. So if we would like to cover a wide range with a low number of measurements, we can increase tenfold. Or if we would like to make a fine-grained analysis, we can just double the number of the size of the number of destination port numbers. So then we can do a lot of measurements. Next slide, please. Yes, and this is something maybe unusual, what I will say, but it's really the reality in stateful NAT64 gateways that they are many times implemented in software. So you don't buy a device, this is a device, but you download the software, many times free software, and you just install it and set it up and use it. For example, which I used is Joule, or it's a bit slow, but it can be also used Tiger plus IP tables, because Tiger is a stateless one and it needs a stateful counterpart. And also I used OpenBSD PF, and FDIO BPP also implements stateful NAT64. So many times we use a software for stateful NATXY implementation. However, our typical view, at least I would say in my typical view is that we have a tester and a device under test. I was talking about that a few minutes ago. But in this case, we're not testing a device because the software is not bound to a specific hardware. So, but it's not really useful that we can know that we have a given implementation using a given server and we measured something. In that case, we don't know how it would perform in a different server. So what is more useful for us in this case, perhaps the performance of a given implementation using a single core of a well-known CPU, and even more that the scale up of the performance of a given implementation with the number of CPU cores. An efficient solution can be that we use powers of 2 as active core numbers, so 1, 2, 4, 8, etc. In this case, with a few measurements, we can cover a wide range of number of CPU cores. Next slide, please. Yes, and one more thing which was missing from our draft, and it is present in several other drafts, that we should specify a reporting format. Of course, the very first thing is that measurements must be executed multiple times, and the number of measurements must be included in the report. And if we have multiple results, then we need to use some summarizing function. We recommend median as a summarizing function because it is less less dependent on outliers, less sensitive to outliers than average. And of course, we are also interested in the dispersion of the results. So first percentile, 99th percentile can be used as an indices of the dispersion. And of course, it's very important that all parameters and settings that may influence the performance of the device under test must be reported in the results report. And it is also some cases, there are some implementation specific parameters, for example, hash table size and connection table size for IP tables, which don't exist for other implementations. So these things also must be reported. Or another example was here is the number of limits for OpenBSD. And okay, it's go. Thank you. You did very well to go to next. Okay, thank you. And here's a reporting format. So there are some required quantities. For example, in this example table, we measured the maximum connection establishment rate of IP tables, agents, the number of sessions. So of course, as an independent variable, we must have the number of sessions, which are not just random, but the product of source port number and destination port numbers. And here there's 2 examples for the hash size and connection tracking table size, which are specific to IP tables. And here's one very important calculated value, which is the number of sessions per hash size. It means that the implementation of IP tables has a hash table, and from each entry of the hash table, a linked list is started. And these numbers, these 3.05 and 3.81, etc., these are the average length of these lists, which is very important. It really determines the performance of IP tables. And of course, the number of experiments and the error of the binary search, the difference between the lower and upper bound. And here comes the real result. Of course, the measured connection establishment rate, the median, and the first and 99th percentiles. Let's go to the next slide, please. Yes, and for discussion, we put some slides for discussion. For generating multiple network flows, we proposed to use only a single source IP address and destination address pair and multiple port numbers. And currently I'm in Tokyo and do measurements with the before mentioned implementations, Joule, Taiga plus IP tables, and OpenBSD PF. And I found that this solution works properly with Linux because the servers which I use support receive size scaling. So if I set properly the RSS function, then not only the IP addresses, but also the port numbers take part in the hash function, and I can distribute the interrupts of the packet arrivals among the CPU cores. So all CPU cores take part in processing the interrupts. However, it's not the case with OpenBSD. So I just checked with the top command, and I saw that as I used the bidirectional traffic, two cores were working to process the interrupts, and the other cores were not working because there were only one IP address pair, and in the other direction they were exchanged, but the source port number, destination port number didn't help to distribute the interrupts among the CPU cores. But of course, it's not the case if this device forwards internet traffic. So maybe we could improve the situation. Could you go to the next slide, please? So our question is that we should add the requirement of using multiple IP addresses, because in that case, the measurement results would be closer to those that one could experience when the gateway processes internet traffic. And we have just one more slide. Please go to the next slide. And I was talking about scalability, and we recommended scalability is the number of network flows. We used for this the variable size destination port number range to set different numbers network flows, and we recommended the scalability agent the CPU core numbers, the active CPU core numbers. And I think both are important, but our question is that is there any other type of scalability that would be important to examine? So we have these questions, and we would like to get feedback from you. Thank you very much.
Okay, thanks very much, Gabor. On your last couple of topics, any input from the folks in attendance?
It's Edward, if possible. I have a comment about scalability, what to test, because I had some experience many years ago about to test primarily firewalls, but not just firewalls. Any stateful device has typically four limits, and four limits was tested by me many times in the past. The one limit is number of flow, the top number of flow which particular device is capable to handle. It's more or less just one number. It's static number. It's just top number which possible to squeeze in the box. But additionally to this, it was as usual mandatory to test such things like GBPS, gigabits per second, PPS, packets per second, and CPS, sessions per second, new sessions per second. It typically was 4 parameters. For static table, how many flows device is capable to handle, it was just one number, which is easy to test, it's separate test. But for combination of CPS, PPS, and GBPS, it was always a mix. The more GBPS you will request from the box, the less PPS and CPS you will get. The more CPS you will ask, the less. Therefore, it was always the combination. It was typically the combination has been decided by looking to the real customer production traffic. You look to any customer box, decide what is the real situation between GBPS, MPPS, and new sessions per second, decide what is a mix, what is a typical situation for the customer, and then to test this one. And how to do it in benchmarking case, I don't understand.
Okay, let me also share my experience. So I completely agree that usually there's some upper limit for the number of sessions. For IP tables, we could exactly measure it, and of course, we knew it in advance what we set for the maximum number of connections, and we could measure it very accurately. But as for Joule, we were not able to measure it because it seems that it doesn't have a real limit. The limit is the amount of memory. So when we just increased, finally the computer stops working. I don't know how it is implemented, but it can just trash the data structure until it has some free memory, and then it crashes.
You are right that with this comment, because you typically test software box. I have in the past experience to test hardware box, and for hardware box there was a limit. Of course, it was primarily memory based, as you said, but it was pretty much a limit, and sometimes it was a limit really for production. Maybe you are right. Maybe for your case, because you test something software based and it's just a memory. Maybe in your case, the overall number of sessions which is capable to squeeze, maybe it's not important. Maybe you're right. Maybe not. I'm not sure about this. But for combination of CPS, BPS, and GBPS, I believe you will have exactly the same problem. The more GBPS you have, the less PPS you have, etc. This mix would be still a mix.
Yes, I totally agree with you. What I experienced, it was the same. But to some extent, I had experienced something different, because if I use fast enough network interfaces, currently I use 10 gigabit interfaces, up to a while, it's the number of packets per second is not, I don't want to say independent, but nearly independent from the packet size. So if I use 82 bytes or 128 bytes or 256 bytes, the packet rate, the achieved maximum packet is very similar, because the bottleneck is usually, in our case, in my measurements, is the handling of the packets, and not the transmission through the network interface.
Okay,
and I
maybe.
usually I use kernel-based solutions. Of course, if I use Toiga, which is a user space solution, then the copying between the user and kernel space may make slower if I use a bigger frame size. But I experienced the same. But you said that if I use many sessions, then all the others will deteriorate. Yes,
But for sure, even for your software-based situation, you will still should have a big dependency between packet per second and new sessions per second. This particular dependency should be still pretty much big.
Yes, I measure separately the maximum connection establishment rate, and then if I have a given number of connections, then with a given number of connections, I can do the throughput rate. And when I do the throughput measurement, I just separate it, because first I test the number of connections per second, the maximum, and then with no new connections, I measure the throughput and other latency and other things, and don't mix the two. So if I try to mix the two, it will be maybe more realistic. You're completely right, but then it will be very hard to measure it in a repeatable way.
Right. We've got a couple of other requests for the floor here, guys. So let me recognize Vladimir. Go ahead, Vlad. We can't hear you, Vladimir. All right. How about Masiek?
Hear me?
Did you have a question, Masiek?
Yeah, I do. Gabor, thanks very much for a very informative talk. I have a comment about the scalability, specifically number of CPU cores. I noticed that the way you're assuming the flows are load balanced across the cores is using RSS. As we are dealing here with not for 4, not for 6 stateful flows, with the distinction between the forward and return flows. And the forward and return flows are different from the from the RSS hashing perspective, i.e., they will have a different IP header values, IP addresses, if it's a source NAT, and also ports. So if you scale number of CPU cores, it is likely that the forward and return flows will end up on different CPU cores. So the more cores you have, the more work the threads running on those cores will have to do to reconciliate the state or share the state. So that's one thing maybe to consider in terms of evaluating the multi-core scalability on how to scale the DUT, the software DUT across multiple cores. And there are solutions out there that you may consider that scale the cores by running independent software instances and basically load balancing across them from the original flows. But that's just one aspect to take into account on how the forward and return flows are load balanced using RSS.
That's
Hopefully
great.
this makes
Thanks, Maciek, for raising that comment. Gabor, I'm going to have to cut this discussion off, unfortunately, at this point. We've got a lot of other presentations to cover. And so let's move along. Thank you very much for your work on this, Gabor. All right. So let's see here. So I've got a set of slides I can share here on the considerations for benchmarking in the containerized infrastructure. And I think it's Min Nuc Tran who's going to be presenting. Is that correct?
Can you hear me? Can you hear me?
Yes, I can. So let's try to make this 10 minutes, please.
Okay.
And I'll start a timer for you.
Okay. So hello everyone. I'm Ngọc. I'm from Sumshin University in South Korea. So on behalf of my authors, I will present our draft update today. Next slide, please. So the first thing we update in this draft is we polish our draft and reorganize the content inside our draft to clearly show the purpose of the draft. So the draft purpose is provide additional considerations as specification to guide containerized infrastructure benchmarking to compare with previous benchmarking methodology for NF infrastructures. So we reorganize the draft in a way that we clearly show the four additional considerations. That's the additional deployment scenarios, additional configuration parameters, then the true investigation of different container networking models based on the usage of vSwitch and different packet acceleration techniques, and investigation of different deployment settings, such as NUMA and HughesPath, that might make performance impacts on the network performance. Next slide, please. So this is the comparison between our previous draft and the current version. So to increase the draft cohesion and clearly show the purpose of the draft, we have added a new section inside draft, the benchmarking consideration. So by looking at the current version, everyone look at our draft can clearly see what is the additional consideration for containerized infrastructures. So and inside that, there will be four consideration. The deployment scenarios is actually taken from the previous section 3, the overview of containerized infrastructures. So by moving it into this one, the deployment scenario additional one can be clearly seen. Then we add a new, completely new additional configuration parameters. Then we have the networking models, the previous section 4. And inside this one, we update the eBPF as a model with the AF-EDP deployment option. And the previous 16 for performance impacts is moved inside this as well as the consideration number 4. Next slide, please. So this is a detailed update. So the first benchmarking consideration is addition deployment scenario. It actually moved from the previous section 3, the overview one. It's nothing new here. Next slide, please. This is a new section, the additional configuration parameter. And it's just a list of additional parameters that need to be considered when benchmarking containerized networking. So they are the selected container runtime, selected container network plugin, selected packet acceleration networking model, number of CVNF, and the resource allocation to the CVNF. Next slide, please. For the third benchmarking consideration, this is a networking model. So we update the eBPF acceleration model with the AF-XDP deployment option. So previously, inside the previous draft, we only mentioned about the channel listing packet between the NIC driver and the user space using eBPF in the hook only. So there are another development option that's using AF-XDP socket. Is a new Linux socket that allow bypass control path. And this option is used by supported AF-XDP vSwitch like OVS or VPP, and it's also used by the Intel cloud-native data plane. And the second development option for eBPF acceleration is using the eBPF program running inside the traffic control hook and the XDP hook inside the NIC driver. Next slide, please. The last consideration inside the draft is performance impairs. If we make no change, we just move it inside this section. Next slide, please. So in our previous hackathon in 114 and 115, we make benchmarking effort for eBPF acceleration models. So we verify the eBPF acceleration with 4 validation. The first is using OVS vSwitch with the vhost users as a connection between the user space and the port. The second variation is using the VP vSwitch. This one using the MEMIP instead of the vhost users. And both of the vSwitch is AF-XDP supported version, which means that it have an AF-XDP promote driver to get the packet from the eBPF program running inside the driver. And the third variation is the Intel cloud-native data plane is a new project that they have their own Kubernetes plugin. And this Kubernetes plugin that can move the network device from the hot network namespace and directly attack it into the port network namespace. So the port can get the packet from the ADP socket, and the final will be the Cilium CNI. Next slide, please. So we have the results, and we had the two result with 0 packet % loss. So what we can see from this result is that the first thing is VP AF-SDP outperform the OVF SDP because of the MEMIP support comparison with the vHost. The second is that the user space vSwitch using AF-SDP promote driver can achieve similar performance versus the one using the DPTK promote driver. And about the new Intel CNDP, we get POM packet from AF-SDP socket to the port by moving network device from hot network namespace to port network namespace. It can catch up the VP AF-SDP performance with like a side packets. Next slide, please.
Quick question on this. How many flows are in use for this test?
We about the flow, is it one flow?
Yeah, how many flows? Is it just one or multiple flows with the?
I think it's one flow. From
one flow. Okay. Okay. Good. Thanks.
For the Cilium, the ability of Cilium to accelerate performance have already been benchmarked by themselves and published in some of their report. So Cilium can accelerate both north-south and east-west. So compared with other variations, then only Cilium can utilize eBPF for east-west traffic. With other variations, the east-west traffic acceleration is accomplished by the vSwitch itself. Next slide, please. So, and we think that the IETF115 hackathon has completed our investigation activities for all the proposed benchmarking consideration in our draft. So we would like to hear any question and comment from anyone in the working groups that is interested in our draft. So, and we really want this kind of feedback for the WG adoption as the next step of the draft. Thank you.
That's great. Thanks very much, Minh. So, look, one thing I'm going to ask is that, we've got a couple of authors of the multiple loss ratio search working in very heavily with virtualized measurements and, the virtualization technology. I think it would really be really good if Masiek and Bratko could take a look at this and make some suggestions. Do you guys agree, Masiek and Bratko?
I agree.
Good.
I haven't got your audio, Al. I only heard you calling out us, MLR search authors. I guess you're asking for review. The audio I got wasn't legible.
Sorry about that. Yeah, I'm tagging you guys for review specifically, since you're working in, an area very close to this, please.
Sure. Thank you.
That's great. And I'm searching to try to get some review from the Anakin open source project, where we still have a benchmarking project there. Hopefully I'll get some feedback for you there as well.
Thank you.
Okay. Well, thanks very much for the quick review here today. Much appreciated. All right. So then moving right along, we got a couple of talks on the segment routing, and we'll start out with the MPLS segment routing. And Paulo, I think that's you, right?
That's right. Just checking you can hear me properly remotely.
Yes.
Good. Well, it's interesting. I'm the first speaker physically in the room.
Yeah. Well,
okay.
I'm very glad you joined us in person.
Right. So just to introduce myself, Paolo Volpato, away. I'm speaking on behalf of the authors you see listed here. And this is the first of two drafts we have submitted to benchmark segment routing capable devices. Specifically, this draft is about SR MPLS, and there will be the next talk provided by Eduard on SRv6, just as the next presentation. Next slide, please.
Yeah, and by the way, Paulo, I'm going to give you 10 minutes here as well.
Sure.
Which I'm starting now, I think. Wait a minute. Start.
Thank you.
Okay.
I'll try to be even quicker than that.
That's great. That'll help our later. That'll help our later presenters. Please go ahead.
Right. Okay, so I think this is something already known, but just to share a few details, segment routing as defined by RFC 8402 can be applied to two different data planes. As said, that this draft focuses on SR MPLS. Let's say that our starting point is RFC 5695, which describes the methodology for benchmarking MPLS devices. So that is, I would say, our foundational component. What we did is actually to use it as the basis and complement that paper, as well as all the references that you see listed here in the draft, to extend the capability to benchmark SR MPLS. We just need something more than the basic MPLS benchmarking methodology. So that's why we have submitted this draft. Next slide, please. Okay, as said, the SR policy, the SR MPLS policy to be more precise, is instantiated on the packet as a set of labels. So basically, you define a segment list, which is a set of labels you impose to the packet. There is a sort of one-to-one correspondence between segment routing MPLS and MPLS itself. There are three basic operations. Considering SR MPLS, we have the push operation. Basically, you inject a policy, I will say, on top of a packet that corresponds to the label push in the MPLS terminology. There is the next operation, which corresponds to the label pop in the traditional MPLS jargon. So the label, the policy, the topmost policy is removed, and then you do something which is correspond to the next operation that you are instructed to do. And then we have the third operation, which is continue. Basically, it's a kind of one-to-one correspondence to the label swap in MPLS. You just remove the outmost label. So, as I said, it's almost like MPLS, but if you want to benchmark SR MPLS, we have to take into consideration something more. For example, 5695 states you should use a test list of one label, or translated into SR-MPLS, that would correspond to one seed, one segment identifier. Actually, this is not enough. We should consider at least two labels or two seeds in SR-MPLS, because we'd like to take into consideration, for example, traffic engineering. And to do so, you just need two labels, for example. That is to say, we are not yet considering the service layer. So, for example, if you have a VPN, layer 3 VPN, which has or which may have associated another label, yeah, okay, this is not under our consideration. It will be probably for other efforts. Then, again, comparing to the, let's say, basic capability of 5695, we have to change a bit the reporting format, and we have also to take into consideration the control protocol to distribute the seeds, so the segments IDs. Next slide, please. All of that corresponds to the changes we have done from version 02. We submitted two versions, one just after the other in October, to address very good comments we have received from Gabor and Boris on the list. I have to be, let's say, I have to advise that those changes, those comments were equally applicable to both drafts, so the one on SR-MPLS that we are discussing right now, and to the next one on SR-V6. So I'm not going to, let's say, discuss all the topics you see listed here, otherwise we run out of time. But basically, we have provided, let's say, more text to address the comments on the buffer size test, on the reference about using Ethernet or other media that may have the issue of stuffing, bit or byte stuffing. So there is something that should be considered, especially in the performance test. For example, we need to reference how to deal with address randomization to be sure that we equally distribute the traffic flows across multiple ports on a packet forwarding engine, and so on. So you see all the topics here, and I'm pretty sure that Edward, during the next talk, can add more details on that. Next slide, please. Okay, next step. So first of all, we'd like to hear from the community if there are more comments, more inputs or feedback, so new text that we can add to this draft as well as the other one. We are open to co-authoring contributions, so any suggestions here, we are more than open to accept further proposals. And we'd like also kind of to share a kind of early question if the text we have put together is sufficient, is enough. Is there anything that we can add just to start discussing maybe the adoption by the working group? And I would say this is it, all I have.
That's great. That's great. Thank you, Paolo. Any questions for Paolo? Okay. Well, I think you've got, you had some good review last time. Let's encourage that to continue. One question I've asked in the past is there any implementation experience with this testing? Have you got any example results that show that this methodology, is solid and working, also repeatable?
Very good question. We are working on that. So we hope to introduce in the next version some, let's say, data taken from lab tests. There is Louise, one of the co-authors, that is working on that.
That's great. That's great. I think that we'll learn a lot from the lab results that you share with us. And that's when people really get excited, when we start to see some, some real numbers here. So I think, I'll mark that down as an action item for the authors, and we'll hope to see that next time or on the list. That's great. Thanks, Paulo.
Thank you.
Okay, so let's move on to the next one, which is the IPv6 version of this. I just have to find it. There it is. Share. And Edward, you're going to be presenting.
Yeah, I hope you hear me, all right?
Yes, yes,
Okay,
hear you
fine.
very well.
Yeah,
And
next slide,
we've got,
please.
early stop here. We've got another 10 minutes for you.
Yeah, I will be much faster, no problem.
That's great.
Next slide.
Much appreciated.
Yeah. Next slide, please.
Okay.
Okay, I would say that our draft, of course, is primarily based on the primary draft of, or primary RFC of benchmarking working group. It's RFC 2544. But of course, there are many additional things which has been discussed deeply in different drafts, and primarily different RFC. Primarily next to different RFC, which we should mention, of course, it's IPv6 RFC 5180 and it's MPLS RFC 5695. But it's not limited just to this particular RFC. Many things has been taken, especially after comments. Many things has been taken from many other RFC. We have here a little bit challenging situation because the Service 6 from one point of view it's IPv6 with enhanced headers. It's pretty much IPv6, right? But from another point of view, if you look how exactly it operates, it's pretty similar to MPLS. For that reason, it's combination. It's a merge of MPLS technique and IPv6 technique. For that reason, it's a little bit special. Next slide, please. Okay. The Service 6 is pretty much different, fortunately, maybe unfortunately, from MPLS because it has not just different names for what we deal with here. It's just not source node or segment endpoint node or transit node. It's not just different names, different syntax. It's different semantic because if you will look to transit node, for example, transit node is a node which does not understand the Service 6. It's just normal IPv6 node. It's something pretty different from MPLS. For that reason, it needs special procedure. And as already Paulo mentioned, we have some restrictions which we put on ourselves. Just it's our decision. Maybe you will tell that we are wrong, but we will change. But we put decision that we should limit draft to some reasonable size. And for that reason, we have put aside services. In MPLS world, it's different to decide what is service, what is transport, because it's different label in the stack. Here, it's more complex because here one seed could have part of the seed is a transport, is effectively the destination node, and part of the seed could be the service. And for that reason, we have discussed here in the draft why we have put aside services, because it's possible, of course, to discuss services, but if we will put here services, the draft would be, from our point of view, is extremely big because number of services, especially for services, could be huge. And for that reason, services are out of the scope here. Next slide, please. As Paulo mentioned, from the last presentation, we have a big update, a really big update from my point of view, because thanks for Gabor, thanks for Boris. They have pointed to us to many things which could be improved. From text size point of view, we changed something like, from my point of view, maybe 15%. Maybe 15% of text has been changed, but from logic point of view, because the changes are in different, effectively in all chapters, yeah. And for that reason, the logic change is much bigger, something like 30% of change. Therefore, the current revision, by the way, it's not 0.2. We have a little bit small update, 0.3. The current revision, which you could find on on the internet is much different from 00. For that reason, we ask everybody to read it again, because after Gabor and Boris comments, it's a pretty big change which we did here. Next slide, please. As you said already, as the chair said already, maybe to proceed for adoption, we need to show the test results in the real lab for some particular, look into this particular methodology, test in the real lab. For that reason, maybe we are not ready for adoption just because we don't have a test lab. But from the text point of view, it looks like pretty good already. But anyway, if somebody will read it again and make some additional comments, big thanks. We are very happy that anybody will give additional comments. That's it from my side.
Thanks very much, Edward. I think that your appeal to folks who read this before and provided comments, now that you've made a huge update, as you put it, it would be good if some of those reviewers would go back and see that that their wishes were realized, and that would be great. So, folks, if you've read the draft before, I'll ask you to go back and take a look at this and see, see what's changed, and if you now like how the authors have dealt with the new situation. Also, I really welcome the implementation of the tests. Like I said before, we'll learn a lot from that. The authors will learn a lot from that, I think, and we'll see we'll see what implications that has for the test methods and the logic, as you put it, Edward. So thanks for volunteering to find a way to do that. I much appreciated. Okay, any other questions from the group? Okay. There seems to be a comment here. Oh, and Boris says he will read again and provide feedback. Thank you, Boris. Okay. Well, thanks for both the pieces of work on segment routing. I think you guys have gotten some good review and now some good input for making progress. So thanks again. Okay. So we can do an early start. All right. So I think, if I'm not mistaken, we've reached our last talk. And I'm going to put we've got about 15 minutes, but I'm going to put 10 minutes on this anyway. Zeki Lai is going to present this. Zeki, have we got you in the queue here with your with audio? Yes, and it looks like you're ready to go. So
okay.
Please proceed.
Can you hear me? Hello, Al.
Yes. Yes. Hi, Zeki. Okay. We can hear you now.
Okay. Hello, everyone. Very happy to have this chance to introduce our latest works on the considerations for benchmarking network performance in integrated space and terrestrial network. So here we go. The next page, please. So now we are entering a new age of satellite internet. Recently, we have witnessed a rapid evolution in the aerospace industry, and many big players are actively planning and deploying their satellite constellations in the low Earth orbit to provide internet access globally. For example, as November of this year, Starlink has already launched more than 3,000 LEO satellites, providing internet access to over 500,000 subscribers in about more than 14 countries and regions. It also aims for global mobile phone service after 2023. And in addition, many additional public satellite internet constellations such as OneWeb, Kuiper, Boeing are also in parallel developments. These emerging satellites can be integrated with existing terrestrial networks, building an integrated space and terrestrial network for pervasive and performant internet service globally. So this is the background. The next page, please. So on one hand, like in other kinds of conventional networks, network techniques such as the new network topology, protocol, functionality are expected to be carefully evaluated in an isolated test environment, we call it ITE, before they are deployed in a live production environment. And on the other hand, unlike traditional situations, ISTN core infrastructures, for example, these satellite routers, switches, are hard to upgrade after launch, especially for their onboard hardware. Thus, it requires a more systematic and more comprehensive evaluation before the launch. Last time in IETF 112, we showed our preliminary considerations for the problems and requirements of evaluation methodology for ISTN. Here is the link of our previous draft. And this time, we also have some question left over. We believe this question should be clarified before our further question. For example, what aspect of ISTN related problem can be pursued for benchmarking network DUT and SUT? And also, we need to clarify the work scope that fits the charter. So next page, please. So this time, we try to first clarify the work scope that is relevant to our fit of our charter. I think the major goal of our BMWG is to consider a series of recommendations concerning the key performance characteristics of internetworking technology. So here we summarize 5 important aspects that might fit the charter. They are, for example, we need to discuss what play an important role in the ISTN performance, for example, the constellation topology, network protocol running upon that, and the hardware capacity. And what is the key performance characteristics pertinent to ISTN, for example, the service quality, service availability, and the reliability. Third, and we think we can discuss the important metrics describing the above characteristics, for example, the user perceived latency, throughput, loss, or routing convergence. And we also need to clarify how to specify methodologies to correct these metrics above. For example, what is the expected in-lab benchmarking methodology for ISTN, and what is the concrete approach and test cases we need to use to benchmark the ISTN technology or functionalities. And finally, we also can need to describe the common and unambiguous result formatting formats for using this to benchmark, to report the benchmark results. And in the next page, we will elaborate the considerations for the methodology and to benchmark for this in-lab benchmark. So here we consider data-driven emulation-based benchmark approaches. This includes, at high level, this approach includes 3 key steps. We call them public data collection, test environment setup, and running the test. Next page, please. So the first step, we call it community-driven public data collection. As we all know that LEO satellites are public network infrastructures and operating in the outer space. So many constellation level information such as the number of orbits, the number of satellites per orbit, inclination, altitude can be obtained from the public community. So such topological information can be obtained to help us to build the isolated test environments. In addition, there are some other measurement platforms allowing users to share their network measurement. For example, this is a Starlink result shared by the speed test platform. So this relevant data can guide us to reasonably build and configure an isolated test environment in our laboratory. Next page, please. Next, please. Thank you. The second step, we call it real data-driven ITE setup. In this step, we can build an ITE via virtual machine or container-based emulation. The emulation should mimic the satellite behaviors such as the time-varying topology, distance, visibility, connectivity, and the network conditions. So this figure shows an example. If we want to build an environment to mimic a real ISTN like this, for example, the last picture with 2 orbits, Then in our lab environment, we can use two machines to create a virtual representation of this environment. So like this, in each machine, we run a number of virtual machines or containers to emulate the satellites and manually configure their connectivity, network conditions to mimic the time varying distance, visibility, and other properties. Next page, please. And in the third step, we specify the device on the test or the system on the test. For example, one day maybe a satellite operator or a research group developed a CubeSat with a satellite processor. It runs a customer or modify the TCP IP stack, and we want to test its network performance and power consumption. In our lab environment, we can use a cluster as the right picture to build an emulation, including a large number of virtual satellites, depending on the constellation size you want to test. Then we can connect the hardware, for example, a device under test running the protocols or functionalities. We can call it system under test to the emulation, and we can build a hardware in the loop test environments. We can generate ISTN traffic, for example, using some tools like iPerf to load the interactive traffic in the lab environment. And we can measure the performance. For example, if you want to evaluate a new routing protocol in space, or evaluate the TCP or quick throughput in an emulated ISTN experimental environment. Next page, please. Okay, so as our next step, we hope we can have more further discussions and clarifications to narrow down the scope of our work. For example, we think these aspects may fit the charter. For example, the class of network functions, systems, or services that are important in emerging LEO satellite internet constellation or ISTN. The key performance characteristics pertinent to ISTN, and a set of important benchmarking metrics, concrete benchmarking methodology, proper test case tailored for ISTN environments. We also mentioned that we indeed have some collaborators from the industry. For example, we have some collaborators from the satellite operator. For example, China Telecom, they indeed have some environment for their mobile telecom satellites, broadband satellites. In addition, we are also working on some tools and platforms for operators or researchers to build a lab level test environment. For example, we have some open source, we call it StarPerf, and also we have a container-based large-scale ISTN emulator. We hope these tools can facilitate the ITE creation for ISTN benchmarking in a more flexible and convenient way. Next page, please. So that's all. I'm running out of the time, and thank you very much. And any comments or questions are more than welcome. Thank you.
That's great. So you've got StarPerf and StarEnet here, which are I guess they're funded projects.
Mm-hmm. Yes, there are some research projects. We also have some open source codes, maybe preliminarily used for education or researchers that can fast build a test environment in their lab environment.
Okay. I mean, that sounds like a good place for some of this work to get started in the lab. And
yeah,
I guess maybe let me first say the number one, thanks for the talk. And I wanted to point out
thank you, Al.
something I missed here, that you've actually got two drafts going. You've got this BMWG SIC benchmarking, which I think is really tuned into the material that you talked about here today in the slides. Is that fair to say, Ziggy Lai?
Mm-hmm.
Okay, and so we've really got two drafts that we'd like people to be taking a look at.
Okay, thank you. Maybe we can, in our next step, maybe we can focus on the first one, the SIC benchmarking.
Okay.
Mm-hmm.
Okay. That's good. So you're kind of leaving the other one on and behind for now. But I think this first one here is really focused on our particular needs here, and I think that's the right way to go. So thanks for preparing that. So
Thank you.
let me open it up. Any questions in the room for Zeki? All right. Well, I have a question and a comment, Zeki. I think that when you start to pursue emulation,
Mm-hmm.
I think you I think really all of us will benefit from the the possibility where you describe your the emulations that you come up with in let's say peer-reviewed conference papers, so we can get some wider review, beyond the benchmarking methodology working group, and maybe draw on some of the folks in the industry whose expertise is more in the satellite internet constellations and the work that's going on there. Would you tend to agree to that? Kind of a higher bar for getting our emulations. I think that would be a really strong step of a foundation that we could stand on here.
Okay, so sure, thank you for your comments, and maybe next time we can show some of our emulation results. Maybe I think we can further narrow down the scope of our work. Maybe we can focus on a certain protocol or service or functionality related to this satellite internet constellation.
Okay. But like I said, anything in the emulation category, I think we're going to want other people in the industry to weigh in and say that, it's a reasonable emulation or it needs work. That's the kind of feedback. I think, just speaking as a participant, I'd feel much more comfortable if real experts weighed in on this. Okay.
Okay, as I said, maybe I can ask some of our collaborators from the real satellite operators to join this meeting next time, if possible.
Okay. Sure. The more the merrier. In fact, I don't think we'll be able to complete this work without adding up, some number of real experts beyond yourselves as the co-authors who can help us here. So, we want to get the strong review and then a strong foundation for this if we take it up.
Yeah, I see.
Good. Well, I think then, the path forward here is anybody who's interested in LEO satellite communications, and it's becoming more and more popular every day. I encourage you to read this first draft that's on the screen and provide your feedback. And let's try to get, let's try to make some progress on this and also the other topics, which are candidates for BMWG work between now and our next meeting next March. That's the goal for all of us. It requires doing some homework, reading the drafts, providing comments on the list, and just being helpful to one another. So, for example, Zeki Lai, you could take a look at some of the other work that has been proposed already today. Yeah, and really that's the way all of us help each other and get this work done. So I guess that's it. So any final comments on the topics that we've talked about today? Feel free to jump up to the mic and volunteer for something or say that we've got a, it seems like we're working in the right direction. Okay. Well then, with no final comments, thank you all for your participation today. We had a good meeting. Looks like we're finishing up right on time. Covered a lot of good topics. I think with the additional work in the laboratories and reviews, that we'll make more progress on this and all our work and really have a great meeting next time around as well. So see you on the list, and I hope we'll have good holidays, and I wish everybody some rest over the holidays and New Year. Let's join up together in 2023 with lots of good stuff done. See you then. Bye-bye.
Thank you. See you.
Bye, everybody.
Thanks all. Thanks everyone.
Sure thing, Masiak. Thank you. Thanks, everybody.
Poi magari lo becco e glielo chiedo, dice magari non è Paolo, non devo andare in prossima, se vai due lui. Allora dai, ci sentiamo dopo.